Hey there, everyone. Ryan Schul with Straight Data Science. So today I want to look at a topic about hyperparameter tuning, and we're going to do this in an automated fashion. So what is a hyperparameter? It's basically a setting or configuration that's external to the model, and you define it before training begins, and it controls how the model learns. So you can say, well, I have a random forest regressor or random forest classifier, and I want to go 10 steps deep or 20 steps or 100 steps or whatever it is, and that's going to stop, right? You can set it to many, many, many more steps, and it might learn different nuances of the data set and get like a little bit better predictive capabilities, but it might take a long time to do that, right? There's always a trade-off between how much time it costs and how much compute processing power that you could put into this and what is the ultimate predictive capabilities of the model, right? But like there's a bunch of hyperparameters that you can set up. So you can do that manually. That's very easy to do manually, but it's very time consuming and you have to run lots of iterations and so on and so forth. And you can spend days, maybe weeks, maybe even months training all the hyperparameters. But there's actually a way to do it automatically and let the computer train and test the model and see what the predictive capabilities of the model is automatically, so you don't have to do this manually, right? So that's the objective today. So let me take you through it. And we do this just to make the hyperparameters tuning process more automated, um, less interactive with the user. You just want to click a button and then walk away, go get your coffee, come back, and everything's done. You don't have to worry about manual guesswork or, is the model underperforming, overperforming? This is going to help the model to perform to the best of its capabilities and better handle complex models capabilities and just automate the entire pipeline, right? Like I spent the first 10 years of my career in automation, just helping people to do something that is repetitive and redundant and done the same way over and over again. Write some computer script so you can click a button, and instead of taking 10 hours to do some job, it can be done in 10 seconds, right? So automation is really a key um, to efficiency, right? To your whole job. So I set this up with the mtcars data set. This is pretty classic. If you've been in data science, you know what I'm talking about. If you don't, then welcome to the club. Welcome to the party here. This is mtcars. We're looking at miles per gallon, number of cylinders, displacement, horsepower, so on and so forth, gears, carburetors for a car. It's a bunch of different cars, very small data set, very easy to understand. I have a couple different topics on my channel about mtcars. I like this one a lot. It's one of my personal favorites. So I'm going to go ahead and assign all of the independent variables and then make a prediction on the dependent variable. So for the regression, if you've seen some of my other videos here, when you do regression, you're looking for a deterministic output of some kind of numerical feature, right? So I'm going to set this to miles per gallon. Based on all of these conditions over here, or all of these features over here, we can determine what the miles per gallon is going to be. So if all these features are this right here, we know this is Mazda RX-4, and we know that the miles per gallon is 2.1, right? Because the model knows this. It's been trained and tested and knows what to do. Now, if you have a car that is not named a Mazda RX-4 but has similar features, 6-cylinder, displacement, horsepower, so on and so forth, you know it's going to be about 21 miles per gallon, regardless of the name. That's irrelevant, right? That doesn't even matter, right? That's what we're trying to predict. And for the classifier, I'm doing two. So I'm doing a regressor and a classifier both together. I could do two different videos. I'm just going to consolidate everything into one. So we have the miles per gallon as a regressor and the number of cylinders as the classifier, right? So again, I'm merging all these into one. So I have Y regression, Y classifier. The Y variable is the predicted value or predicted variable that we're trying to get to. And all of the independent variables is everything else, right? So these are going to be the independent right here, what I'm highlighting. And this is going to be the dependent regressor, and this is going to be the dependent classifier. And I'll give you all this code when I post the video so you can copy it and run it in your own environment. So we're doing the train test split. This is just basic, very, very basic machine learning right here. And the most important thing here is this part right here. So this is where we're doing the hyperparameter tuning. So we're setting like a lower threshold and an upper threshold and saying, computer, I want you to run through all these iterations. I'm not going to manually tune this thing, okay? Because it's going to take days, weeks, or months to do this. I want you to iteratively, that's hard to say. It's hard for me to say some of these things. We're going to iteratively go through every single scenario and every combination of every possible scenario in this dictionary. Anytime you have this kind of setup, this is a key value pair. If you have the curly braces without the semicolon here, or colon, I guess that's called colon, then that's a dictionary. If you have curly braces just by itself, that's a tuple, and the square braces or square brackets is the list. Those are the data types in Python, right? So you have the number of estimators, maximum depth. That's how deep the model is going to go for its training. Minimum samples and splitting, and minimal samples for leaf. Remember, this is random forest regressor, so you have the tree, and then you have all the branches and then all the leaves on the end, and the maximum feature is the square root and the log, right? So we have this whole setup here. And remember, the RandomizedSearchCV right here, or parameter grid, sorry, it's parameter grid. This is the hyperparameter tuning scenario with all the limitations. So you have the upper and lower, and you have the guardrails right there, right? And we're looking for different combinations of hyperparameters to see which one is best based on the scoring metrics, okay? And for each combination, it trains the model with k-fold cross-validation, so it trains one and another and another and another and another. And I have a video on my channel about this, so you can look for k-fold validation if you're interested in that. And it evaluates all the performance, RMSE, root mean square error, and then the accuracy, right? And then it selects the best outcome from all of these. So that is the regression part of it. Now we're going to do the classifier, okay? So move on to the classifier. I'm going to run that, and kind of the same thing, right? So random forest classifier right here. Before we used random forest regressor. Okay, that was regressor is right there. So kind of similar. It's very interesting. I like this random forest classifier and regressor, and I like XGBoost random forest. I'm sorry, not random forest. XGBoost classifier and regressor. These tend to perform pretty well in on most given data sets, whatever you're doing. But I have a whole another video on my channel about like trying a whole bunch of different models automatically and running through about, I think it's up to 40 now. You can loop through all these different models and test the outcome of each one and see what the performance is. Then you pick the best one. But typically, in my experience, the random forest classifier or regressor, depending on what you're doing, performs very well. And XGBoost regressor or classifier tends to perform pretty well. So again, we have the parameter grid CLF classifier. That's just short for classifier. Over here, we have regressor. REG is for regressor, right? But we set up these parameters, and again, we go through all the iterations of every single possible combination of everything in the whole universe, right? In the whole machine learning universe, and see what the outcome is. And again, we're looking at all the possible combinations. We train and test, do k-fold cross-validation, evaluate the performance of each one, and then select the best model based on the scoring and the metrics of each one. So let me hit Control Enter down here and run it. So before tuning, we had an R-square of 0.8593, after 8797. So it definitely increased. After we added in the automatic hyperparameter tuning, the R-squared improved. So in the first case, the model was able to make predictions about 85% of the time it's accurate, what the miles per gallon is going to be. And after tuning hyperparameters, it's up to 87, right? So we had a slight boost there, and the error decreased from 2.3 to 2.1. And these are tightly coupled, right? Like if the R-squared increases, then the root mean square error decreases, right? So you're able to make better predictions. This was actually very interesting to me. The accuracy before tuning was a 0.8571, and after tuning was exactly the same. You can see the precision was the same, recall and F1 score was all the same. So the auto hyperparameter tuning didn't really even help with the classification part, but it did add a slight improvement, about 2%, with the regression. Okay, so why would this even happen? Basically, there's a few different reasons. I think the classifier is already close to optimal or at optimal. It couldn't really improve even with the hyperparameter tuning, or there was not enough data. This is kind of like a smaller data set. If you have hundreds of features and millions of rows, then the automatic hyperparameter tuning would probably help you. In this case, it helped with regression, not with the classification, but whatever. It did what it was supposed to do. It certainly didn't get worse, right? It tried every possible combination, and I think it was already optimized at the beginning. I think that's what the outcome is. So hopefully that shows you how to automate these features. Sorry, not these features, but the hyperparameter tuning process, right? To save you time as a data scientist or as a machine learning engineer, and just to make your business more efficient and make your models more efficient, make your learning better. Okay, that's the whole point of this. So hopefully I could drop some knowledge, and this was educational and informational. I'm going to wrap it up here. I will save all the code as is, and I will share it when I post the video later today. Thank you so much for your time, and I will see you in the next video. Goodbye for now.